Okay, we have two switches to control the direction of the conveyor belt. Then we have two feeders to release the ball, and there is attached three sensors, proximity sensors and also magnetic sensors to detect metal on the box. We have a single acting cylinder and also double acting cylinder to control the releasing of the ball. Right here we have three pneumatic 5-2 directional valve actuated with the spring retain to control air inside the acting cylinder. We have PLC, and we also have relay A and B to control on and off, and also the direction of the conveyor belt. We have also the Raspberry Pi to connect with the pneumatic system and with the Phyton by GPIO. We have right here DHT22 to detect temperature and humidity. And lastly, we have interface circuit to connect between computer and also input and output of the system.
About the wiring part of the system. For this system, we have two main types of the wiring, which is the solenoid, so the sensor. So for the solenoid, we have two wires. One is the red wire, another is the black wire. So the red wire will be connected to the dual row strip block to be connected to the positive terminal of the power supply. And another one, the black wire, will be connected to the interface circuit so that the GPIO pin of the Raspberry Pi can be paired to the interface circuit. So another one is the sensor. The sensor, there is three types of the wire. One is brown, one is blue, and one is black. So for the brown, it will connected to the positive terminal of the power supply, and the black wire will be connected to the interface circuit. And also the GPIO pin of the sensor will also be connected to the terminal of the interface circuit. And the blue wire, the ground wire of the sensor, will be connected to the breadboard, which have all the negative terminal. Then all the negative terminal will be connected to the ground terminal of the power supply. Same as all other ground wire, it will be connected to the negative terminal.
So I'm Danai, and I'm gonna talk about the box design. And as you can see, this is made from the recycled material, and the dimension is specified to fit the conveyor so that it does not have any interference on it. And the same goes to the height. And also you can see there's the hole here. Okay, so that when the ball falls, you can see that and track the balls. And also the metal plate, it is used to trigger the proximity sensor as it goes through the conveyor. And also it's designed like this because it is space saving and also easy to be
for my part, setup. So firstly, we connect the Raspberry Pi to the power supply, and then we connect our Raspberry Pi to monitor. We use as a display device, and then we use keyboard to input, and we use mouse. Then next we open the Codify. And then standby. and then we open the switch for PLC and conveyor. This one. Okay, for next, we open for the pump. Then we test the solenoid. Next, we test the sensor. Yeah, light up. Next, okay. And next, we run the coding.
So now I will explain about code for the system. In the first block, we are trying to import the modules into the system, so we can use the GPIO pins from the Raspberry Pi, and also the TH322 and the sleep module. In the second block, we are defining the pin numbers into several variables, so we can change the pin numbers easily from here. In the third block, we are setting the direction of each component into input and output state, and from here we can see that the numbering system we use is BCM. In the next block, we are creating a function called read TH322, so we can call it when we are running the code. So in the while loop, which represents the whole body, the body of the code. In the first three lines, this will display the temperature and humidity data onto the screen. So in this if block shows that if both the switches, which is switch black and switch red, is not triggered, which is in true condition, the relay A and relay B will be high mode, which will move the trigger the conveyor start to move to the right. Because the relay A is represent on state and relay B represent the left-right direction. High for relay B means right direction, and all the actuators will be high mode, so they will be expanded. In the next block, when the metal plate on the box is sensed by the lab sensor, the both relay will be low mode, which will stop the conveyor, and the top left cylinder will first retract and extended, followed by the bottom left cylinder. So the first ball will be thrown into the box, and the conveyors will continue move to the right until it is sensed by the right sensor, which will trigger it to the false condition. So the conveyor will be stopped, and the retraction extension of top right cylinder and bottom right cylinder will be repeated for 3 times, so that 3 balls will be dropped into the box. After this process, there will be 4 balls in the box. After that, the conveyor will continue to move to the right. So in this time, we need to change the direction of conveyor back to the left by triggering the red switch to be false condition. So by pressing the red switch, so the relay A will still remain high mode, which means remains on, while relay B will be in low mode, which is left direction. All the actuators still remain as high mode. So the box will back and sensed by the right sensor. So the whole process is same as previous one, except the conveyor
After the 3 balls drop into the box, the conveyor will continue to move to the left. So in this time, there should be 7 balls in the box. So in the second last loop, metal plate on the box will sense by the left sensor, which will trigger it to the false condition. So the conveyor will start. The top left cylinder first retract and extend, followed by the bottom left one. So it will drop the last ball into the box, which is the 8-1. So the conveyor will continue move to the left, and we need to stop it by trigger the black switch to false condition by pressing it. So the both relay will be low condition, which will stop the conveyor. So the demonstration of how the code control the action of conveyor will be shown in the
project, I learned about Raspberry Pi, about the coding, Linux, Python, that I never know about it.
Okay, based on the project, I learned how to integrate between the coding and also mechanical parts to, in our case, we have to make the ball into the box, so integrate our skip into the machine.
Throughout this project, I've learned the wiring connection between the Raspberry Pi and PLC so that we can operate the numeric system, and also we have learned how to write Python programming to control the numeric system to drop the ball like block.
In this Mechatronics project, I'm able to know how to connect the wire between each component correctly so that the system works. I'm also learned how to use the Python to write the code which determines what the output devices like solenoids need to do, because the action of solenoid depends on status of input by sensors. That's all.
Okay, so from this project, I learned how to use the Python to code multiple types of the sensor like DHD or proximity sensor, and also I learned how the PLC works.